Welcome to another tutorial by Recurring Reflections. In today's topic, we'll be focusing on quadratic functions. So with no further ado, let's get started. Quadratic functions are also known as parabola functions. So let's get started. The first thing that we are going to do will be the general formula, which is y. It's equal to ax squared plus bx plus c, or it can be y. It's equal to a open bracket x plus p close bracket all squared plus q. So now let's go to the shape of the parabola or the quadratic function. On the shape, if a from the general formula is greater than 0, so then the shape of our quadratic function will be smiling. And if a is less than 0, then our quadratic function is frown. So that's it with the shape. So right now, from the general formula, let's go to the value of c. The value of c. What we have to know about the value of c is that the value of c can also be equal to q. So if q is greater than 0, it means that the turning point, I'm just going to write TP to represent the turning point, is on the left of the y-axis. And if q is less than 0, it means that the turning point is on the right of the y-axis. With that being said, you also have to know that when we calculate our turning point, or the value of our turning point is given by, which is TP, is given by the value of the axis of the symmetry, which is minus b divided by 2a minus b. And to find the y value of the turning point, we take the axis of symmetry and substitute it back in the original equation. So it's going to be f of minus b divided by 2a. To sketch the parabola function, there are a few things that you will need to know, which is, in this case, is the y-intercept, the x-intercept, the axis of symmetry, and or the turning point. The turning point. So right now we are going to be sketching our parabola function. So let me give you an example. Example will be f of x is equal to 2x squared plus 5x minus 12. So the first thing that we are going to find, will be our y-intercept. So when we find or when we calculate our y-intercept, we have to remember that x is equal to 0. So this is going to give us that y is equal to 2, open bracket 0. From the general formula or the general equation, we are substituting everywhere there's 0. With x by 0. Squared plus 5, open bracket 0, minus 12. So this is going to give us minus 12. So y is equal to minus 12. So the coordinates of the y-intercept is 0 and minus 12. So now we go to the x-intercept. Where y is equal to 0. This is going to be 0 is equal to 2x squared plus 5x minus 12. We look for factors and it's going to give us 2x minus 3 x plus 4. And x is going to be 3 divided by 2, or x is equal to minus 4. So remember that 3 divided by 2 is also 1.5. So right now we are going to be finding the axis of symmetry. Axis of symmetry. Using our formula, which is minus p, everything divided by 2a, which is going to give us minus 5 divided by 2, open bracket, 2, close bracket. And this is going to give us a minus 5 over 4. And minus 5 over 4 is also equal to negative 1.25 to 2 decimal places. So to find the y value, we substitute in the place of x in the general equation of f of x. So it's going to be f of minus 5 over 4, which is going to be 2 open bracket minus 5 over 4, everything squared, plus 5 open bracket minus 5 over 4 minus 12. Everything is going to give us minus 121 divided by 8, which is in decimal places is also equal to minus 15.13. So the coordinates of the turning point TP is going to be minus 5 over 4 and minus 121 divided by 8. And one thing that you can notice from the beginning is that since a on the general formula was greater than 0, it means that our function was smiling or is smiling. So right now we are going to be plotting our graph or our parabola on this graph paper. So let's draw the Cartesian plane, our y-axis, and also our x-axis. You always have to remember to label them. So y, this is x-axis, so we'll be naming this with 2, 2, 2, so it will be 2, 4, so this will be 4, 6, 8, 10, 12, and then 14, and so on. So it will be going like that, 2, 2, 2, 2, 2, 2. So remember, on the left hand side there are negatives, and then on the right hand side everything else is positive. So it'll be 4 also, 8, 10, then 12, and so on. It'll be 2, 2, 2. So right now let's get started with plotting the points that we've calculated. The y-intercept was 0 and negative 12. So 0 on the x-axis, negative 12 on y. So which is here. Let's use a different color so that it becomes visible when we plot our graph. 0, -12, it will be somewhere, it will be here. Sorry. And our x-intercept is 0, is -4 and 1.5. So it's -4, which is here, and 1.5. So 1 is somewhere here, so 1.5 is somewhere here. So now we'll look for the axis of symmetry. It's minus, the x value is -1.25, so it's somewhere here, and -15.13, so it will be, this is our 14, so 15.13, 14, 15 is here. I'm going to use light blue, very thin line, to represent the line as the axis of symmetry. It's not that visible. Let me use black. Yeah. So here where I'm doing the dotted line going up, this is the axis of the symmetry. So right now we have to join the points. Joining the points to form the parabola. We have one half. Let's complete the other half. So this is my parabola. Where all the points that we have calculated have a y-intercept, x-intercept, x of symmetry, and the turning point. Thank you for watching, and don't forget to click here to subscribe and click here to watch more videos, and get in touch with us on our social medias. The links are on the descriptions. Thanks. Enjoy the rest of your day.